Here are your solutions to 7-4. These are the letter problems. We will start with letter A. In this case, we are being asked to determine whether triangle ABC, this triangle here, is similar to XYZ, and then explain that. So we could look at the angles here, and the easy way to do that would be to take out a piece of that plastic, trace this ABC onto it, and then translate it over and see how the angles match up. But that's really not necessary because we can just do a side-to-side, corresponding sides comparison. So let's do this. We have 6 to 8 in this case, and I'm not going to change colors here because this one here is corresponding to this one here, and that's also 6 to 8. So we have 6 over 8 for one of our comparisons, and here we have 8 to 12. Now remember, we started on the left with the 6, so we need to start on the left with the 8, so we have 8 over 12 in this case. Well, we can reduce 6 over 8. We'll put that over here. If we divide both numbers by 2, that will reduce to 3/4. And in the case over here, we can divide both by 4. 8 divided by 4, of course, would be 2. 12 divided by 4 would be 3. So we're basically being asked the question, is 3/4 equal to 2/3? And we should know that 3/4 is 0.75 in a calculator, whereas 2/3 is 0.6 repeating in a calculator. So they clearly do not equal each other. So determine whether or not they're similar. The answer would be no, they are not. And then explain. The reason would be because, and now let's go back to our original numbers here and here and say that 6/8 does not equal 8/12. And there's your answer. Okay, let's take a look at letter B. In this case, we're being asked to find the missing measure. Remember, we were told in the previous problem that these two figures are similar. So we know that this is similar to this, and if you look at the orientation here, they made this first problem for you fairly simple. You don't have to do any translation or any transformations in order to map this onto this, other than, of course, the dilation. So in other words, what I'm saying is that these two sides are corresponding sides, these two sides are corresponding sides, etc. So before I get this too full of marks, I'm going to stop there, and now let's take a look at what we were looking for, which was WZ. So WZ is this side, so the corresponding side to WZ is our green line here, which is this figure here, or this line segment here, AD. So now let's take a look at this. We have two numbers here, that two corresponding sides that have a number on each of them. So in this case, we could say that 10 over 15 has got to equal something. So we're going to move from left to right in each of these cases. You could do this right to left as long as you do it in each case. So we're going to stick with left to right. So now we're being asked to find out this length here, this WZ. So we have 10 over 15 in this case, so we need to put 13 over an unknown here. So we have 13 over x. So now we can do our cross multiplying. That's the way I'm going to do all these problems. Most kids find this really simple to remember how to do. So we have 10 times x, that's easy one, 10x equals 15 times 13, and 15 times 13 is 195. Again, we have simple math here. We can divide both sides by 10, which is a matter of moving the decimal place 1 over. So we have x equals 19.5. So that's our answer to letter B, 19.5. Now the next thing that we want to do is find AB. So let's look over here, and right here is AB. So that means that's going to be corresponding sides with WX, which is 24. So we have the same thing. We're going to move left to right, so we can find room here. We'll go 10 over 15. Just like before, right here's our two numbers, 10 over 15 equals x, because we don't know what AB is, over 24, because 24 is the one on the right. So in this case, notice that the x is in the numerator, not the denominator. It's all a matter of position on the two figures you're using. So again, nice easy math. We can multiply, cross multiply, and we have, we'll do it up here, 15x equals 10 times 24, which is 240. Divide both sides by 15, and we end up with x equals 16 in this case. So the answer to letter C will be 16. Key point to remember here, folks, is to first of all always look for the two corresponding sides that both have numbers, and that sets your ratio. And then after that, however you set this up, if you go left to right, then always go left to right on any other corresponding sides. And you're going to always figure out the missing piece by doing a cross multiplication. Please do guided practice. Here are your solutions to 7-4 guided practice. We'll start with problem 1. We're being asked to determine whether each of the pair of polygons is similar, and then explain. So the first one we're going to look at, we can compare 3 to 5. So we have 3 over 5 in one case. We're going to ask, does that equal? So we went left to right, so we're going to go left to right again. Does that equal 5 over 13? And furthermore, we could ask, does that equal 4 over 12? So we can take this. We really didn't even need to put the third one in here, because we can look at this and immediately see that 3 over 5 does not equal 5 over 13. And again, I would urge you to put these both in a calculator. 3 over 5 is quite simple. That's 0.6 in a calculator. And 5 over 13, well, first of all, you really shouldn't even have to put it in a calculator, because it's less than half, obviously. But if you put it in a calculator, you'll see that it's about 0.38. So our answer is no, and the reasoning is because 3 over 5 does not equal 5 over 13. Now, if you did this from right to left, then your answer would be 5 over 3 does not equal 13 over 5. The order does not matter here, numerator and denominator. It's still the same ratio, because the cross multiplication would still work. That's another way to check these, is you could go like this and say that 5 times 5 is 25, and 3 times 13 is clearly not 25, so it does not work. Multiple ways to check these problems, so please make sure you understand how to do some of these different things. Here's your solution to problem number 2. The first thing that you should notice here is that the orientation is not the same. So one of the things you should think about is that we're comparing 18 to 13.5, not to 6. Be careful about that. We're going to compare 8 to 6 like this, and then these two sides, in this case, this side is here. That's also 8 to 6. And then lastly, you have 10 to 7.5. So your four numbers would be like so: 18 over 13.5, and then we also have 8 over 6 in blue and 8 over 6 in green. And then our last one is magenta, which is 10 over 7.5. Take these all put them into a calculator. The easiest one to do is this one right here. 8 divided by 6 would be 1 2/6, which is 1, this is a 2 here, 1 1/3. So this is going to be 1.3 repeating. Check them all in a calculator, and you will see that yes, we have corresponding angles, and your answer should be, because 8 over 6, in fact, I'm going to write it right over here. You would write 18 over 13.5 equals 8 over 6 equals 8 over 6 equals 10 over 7.5, and this would be the rest of your answer. The first part of your answer is yes, second part of your answer is right there. Problem number 3. The two triangles are similar. Okay, they're telling you that. Determine the transformations that map one figure onto the other. Well, we would have to do two transformations. First of all, we would have to rotate it 180 degrees. So we would have a rotation. And secondly, obviously, since they're similar, we have to do a dilation. So we would do a rotation and a dilation, and we could map this figure on top of this. So find the missing side measures. So one of the things we should see right away is once we rotate it, we have 6 is related to 3. So we're going to write 6 over 3, and that needs to equal something. So we've got, in this case, x would end up mapping over 6, so we would have x over 6. So now we need to do our math here and recognize that we have 3x, cross multiply here, equals 6 times 6, which is of course 36, divide by 3, and we have x equals 12. So the missing side measures, we would have x, which was GH, so we have GH, that's a line segment, so we draw that, and that one equals 12, so we've got that one done. Now we're going to do the math for y, so we'll switch to red here. So in this case, again, we had 6 over 3 equals, this is a 9 here, 9 over y. So once again, we have cross multiplication of 6x equals 3 times 9 is 27. So we're going to divide both sides by 6, and we have x equals 27 divided by 6. X equals 4.5, 4.5. So, I'm sorry, this is actually y here. Y equals 4.5. And y was LK, so the rest of our answer is LK equals 4 1/2, 4.5. Problem number 4. The two triangles are similar. Determine the transformations that map one figure onto the other figure. Let's do this. Okay, one of the things you should recognize is that this angle is congruent to this one, and that here we've got 2 tick marks, and here we've got 2, and then this one, of course, would have the 3. So, determine the transformations that map one figure onto the other. Well, one of the first things you have to do is you need to rotate it. So we would do a rotation. It's not going to line up perfectly, so we would also have to do a translation. Sorry about the abbreviations here, but it's quicker. And then lastly, of course, they're not quite the same size, so we're going to do a dilation as well. So there's the first part of your answer. And then it asks us to find the missing side. So we're missing x here. So imagine if you flip this a little bit. First of all, we would have 10 right here over 8. And that needs to equal, so the x, if you flip this over, the x and the 4.8 would be what you're matching up. So the 10 goes with the x, so the x should be on top, and over 4.8. So we would have 8x equals 48. Divide both sides by 8, and you get x equals 6. So find our missing side measure. All we need to do is answer 6 in that case. And lastly, our essential question. How does the scale factor of a dilation relate to the ratio of the two corresponding sides of the pre-image and the image? Easy way to put this is that the scale factor of the dilation and the ratio are equal. Scale factor equals the ratio. So if you would go back to some of those problems earlier and take a look back at that, you will see that the scale factor or the ratio equals the scale factor. So for example, I'll write one of them down here from a previous problem. We had 8 over 6 in problem number 2, or we had 18 over 13.5. And remember, we figured this out in our head to be 1 1/3, so 1.3 repeating was the scale factor. One of those figures was 1 1/3 times as large as the other. So again, scale factor equals the ratio. They're the same thing. Please do independent practice.